Section 3.4 Graphs of Polynomial Functions. In this section, you will recognize characteristics of any sketch graphs of polynomial functions, use factoring and calculators to find zeros of polynomial functions, and identify zeros and their multiplicities. So graphs of polynomial functions. In general, polynomial functions all have this following characteristics. No corners. For this reason, we call polynomial functions smooth. Also, no breaks. And we call any function that has this characteristic, no breaks, that is continuous. Okay, no corners, meaning it's smooth, no breaks, it is continuous. Okay, so let's take a look at these graphs here. Each of the graphs below represents a polynomial function. So look at the first one. If you follow this graph, no corners, no breaks, it is continuous, it is smooth, so this is polynomial. The next one, the v, which is an absolute value. If you follow this graph, there is a corner here, so this is not a polynomial. Okay, how about this one? If you follow this graph, it's no break, it's continuous, so this is, it's very smooth, so this is a polynomial. And how about this one? If you follow this, oops, we stop here and we jump here. So as you can see here, there is a gap. We call this as a jump discontinuity, or just call it as a jump. So definitely this is not a polynomial. So take note that this is not continuous. Okay. All right. Using factoring and calculators to find zeros of polynomial functions. So like an example of Steph Curry, remember that from the other section, shooting a basketball, finding zeros of polynomial functions come up in many applications. As a refresher, whenever you see this term, zero of a function is, meaning that is when f of x is equal to 0. Okay, so let's get practice finding zeros of polynomial functions. In almost all cases, we will either factor or use a quadratic formula. So take note of that, either factor or quadratic formula. Do you remember your quadratic formula? Quadratic formula, that is negative b plus or minus square root of b squared minus 4ac all over 2a. Yes. Okay, so example 2, find the zeros of f of x equal to x to the 6 minus 3x to the 4th plus 2x squared. So let's use factoring. So let's factor that. We can factor out each x squared. Each term has x squared, so x squared So this is x to the fourth minus 3x squared plus 2. And then this trinomial here is still factorable. X to the fourth is x squared times x squared. Can you find two numbers when you multiply is positive 2 and when you add is negative 3? Again, find two numbers when you multiply is positive 2 and when you add is negative 3. Yes, that is negative 1 and negative 2. Because negative 1 times negative 2 is positive 2. And negative 1 plus negative 2 is negative 3. So these are the correct factors. Okay, so we want to find the zeros. That is, we want f of x is equal to 0. So you have factors here, x squared minus 1, and x squared minus 2. So x squared, when you set this to 0, meaning x is equal to 0. So that's the first one. Next, x squared minus 2. I'm gonna write it down here. X squared minus 1, sorry, equals, set it to 0, and then solve for x. So add 1. So x squared is equal to 1, and then square root both sides, so that x is equal to square root of 1 is plus or minus 1. And then x squared minus 2, do the same thing. X squared, set it to 0, and then add 2. And yes, square root, so that x is equal to plus or minus square root of x. 2, sorry. I was looking at the other problem. So there you go. The zeros are 0, plus or minus 1, and plus or minus square root of 2. So these are the answers. And let's take a look at the graph of that given function. F of x equal to x to the 6 minus 3x to the 4 plus 2x squared. If you use a graphing calculator, you will see this graph. And look at the zeros. You have 0 here, positive negative 1. So this negative 1 is positive 1. Also negative square root of 2 and positive square root of 2. So we have 5 zeros of the graph. So you have those 5 x-intercepts, 5 points on the x-axis. Okay. Another example here, find the x-intercepts. I just said here, these are the zeros. Those are also your x-intercepts, the points on the x-axis. So example number 3, find the x-intercepts of the function f of x equal to x cubed minus 5x squared minus x plus 5. So by factoring, so you have 4 terms, so we can use this factoring by grouping. Like I will group the first 2 terms of x cubed minus 5x squared minus x minus 5, minus because minus times negative is positive. Then x cubed minus 5x squared, there is a common factor. I can factor out x squared. So this is x minus 5 minus x minus 5. Now, this is one term and this is another term. You have 2 terms. and each term has x minus 5. So I can factor out now that x minus 5. So I'm going to factor out x minus 5, and then I'm going to have it here, x squared, and understood there is 1 here, so minus 1. So look at this. I factored out x to the 5th, and then I have here x squared and negative 1. So, but still x squared minus 1 is factorable. Difference of two binomials. So that is x plus 1 and x minus 1. So now, what are the zeros? So you can solve x minus 5. That is x is equal to 5, x plus 1, x is equal to negative 1, x minus 1, x is equal to positive 1. When you set each factor to 0. So these are the zeros. You have negative 1, positive 1, and positive 5. And look at the graphical view. You have those zeros, those x-intercepts. We have negative 1, positive 1, and positive 5. Okay. Next, example number 4. Use its graph to find the x-intercepts of the given function f of x equal to x cubed plus 4x squared plus x minus 6. So that's the easiest because you already have the graph, and all you have to do is look at the x-intercepts, the points on the x-axis. So this point, and this point. What are those x values? So meaning those are the zeros. So you have here negative 3, that is negative 2, and this point is 1. So these are the zeros. Next one, identifying zeros and their multiplicities. Look back at the last 3 examples. Notice something about the degree of the functions and the number of zeros that each had. Do you think that there is a pattern? Look at this example, and the graph, and this example. It turns out that there is a very special connection between the degree of the polynomial and the number of zeros. This connection is spelled out in the fundamental theorem of algebra. It's fun. Oops. Which states that the number of zeros, take note of this, of a polynomial function is exactly its degree. Fundamental theorem of algebra. But with one big caveat here, the zeros can include complex numbers. So I'll show you later. So again, the number of zeros of a polynomial function is exactly the degree. So let's go back here. The degree of this h of x is, the degree meaning the highest power, is 3. So that's why you have 3 zeros. Here, example number 3, the degree is 3. That's the highest power. So that's why you have 3 zeros. Here again, the highest degree of f of x is 6. So that's why, to look at your zeros, you have 1, 2, 3, 4, 5, 6. Because, be careful here. because here, look at this shape here. It's like a parabola, meaning you have 2 here. So 2, 3, 4, 5, and 6. And also that is what we call multiplicity. So the number of times a given factor appears in the factored form of the equation of a polynomial is called its multiplicity. I just showed you an example. Okay, we can go back here and I'll show you where is that multiplicity here. So here the reason why, as I explained, this is a parabola and it's you have 2 zeros because look at this, the power here is 2. So that's why I think that you have 2 here. 2, 3, 4, 5, 6. So that's why the degree is 6. Example number 5. What are the multiplicities of the zeros of the function f of x equal to negative 2 times x plus 3 squared times x minus 5? Remember, the first thing that you need to do is, if you can get the factors, do that. So factor your polynomial. Though this given is already in factored form, you have x negative 2, x plus 3 squared, and x minus 5. And we can get our zeros here. X plus 3, that is x is equal to negative 3, and the other one, x is equal to 5. So these are the zeros, right? And then next is, don't forget to count the number of times each factor appears. That is by looking at the power of each factor. X plus 3, the power is, the power is squared. So that's why x minus 3 has a multiplicity of 2. And x minus 5, the exponent is 1, so it's just multiplicity of 1. Okay, so take a look at some examples here. When p equals 1, it's a single 0, so that's why it crosses that x-axis. And look at the 0 with the multiplicity of 2. Look at this 0 here, multiplicity of 2. When p is equal to 2, the shape is a parabola. This is how I always take a look at the difference between the 3. If it's 1, then it just crosses at that point the x-axis, meaning it's just a line. If it's 2, then you should have a shape of a parabola, and then if it's 3, you should have a shape of a cubic. So a line, a parabola, or a cubic. So that's how I always remember this for the multiplicities. So in general, zeros with even multiplicities will only touch even. So this is even. It will only touch the x-axis. meaning it will not cross the x-axis. And then zeros with odd multiplicities like this one, p equals 1 and p equals 3, that is, it will cross over the x-axis. That's why you have this and you have this. So don't forget even and odd multiplicities. Okay, and then now let's work on some lecture questions. This is from the book. Find the zeros of the following functions. Number 10, c of t. So remember, the first thing that you do is set this to 0. So 2t to the 4th minus 8t cubed plus 6t squared is equal to 0. Factor. 2, 8, and 6, they're all divisible by 2. Each term has t squared. So I can factor out 2t squared. Then divide each term by 2t squared. So this is t squared minus 4t plus 3 is equal to 0. And then, is this factorable? T squared is t times t. Can you find two numbers when you multiply 3 when you add this negative 4? Yes, it's negative 1 and negative 3. Negative 1 times negative 3 is positive 3. Negative 1 plus negative 3 is negative 4 equals 0. So now, after you get all the factors, each factor set to 0 and solve for t. For 2t squared, so t is going to be 0 here. For t minus 1, t is equal to 1. T minus 3, t is equal to 3. So the zeros are 0, 1, and 3. That is for number 10. Okay. 13. F of x equal to x cubed plus x squared minus 20x. Set this to 0. X cubed plus x squared minus 20x is equal to 0. Each term has a variable x, so I can factor out x. X squared plus x minus 20 is equal to 0. Now let's see if this trinomial is factorable. X squared is x times x. Can I find numbers when you multiply is negative 20 and when you add is x? Yes, negative 4 and positive 5. Negative 4 times positive 5 is negative 20. Negative 4 plus 5 is positive 1. So these are all the factors. So each factor, there are 3 factors. You can set this to 0. So this is x is equal to 0. X minus 4, that is x is equal to 4. X plus 5 is gonna be x equals negative 5. So the zeros for number 13 are 0, 4, and negative 5. Okay, please practice your factoring. Next, and the last problem for this section. For the following exercise, find the zeros, the multiplicity, and explain what happens on the graph at each 0. So given f of x equal to x plus 2 cubed x minus 3 squared. So these are already in factored form, meaning x plus 2 cubed x minus 3 are squared are the factors. So we can get the zeros. That's the first thing. Here x plus 2 is x is equal to negative 2 and x is equal to positive 3. So the zeros are -2 and +3. So next, multiplicity of each. When x is equal to -2, that is, it has a multiplicity of the exponent 3. When x is equal to 3, it has a multiplicity of the exponent 2. Yes. Now, what happens on the graph at each 0? Multiplicity of 3. So remember, it's an odd number. So this is yes, cross over the x-axis. How about 2? If it's an even, it will touch the x-axis but not cross the x-axis. Okay, and that's it for section 3.4. Thank you.